Hello everyone. Welcome you all in the today's lecture. Today we are going to deal with the concept of the black body and some of the terms which are related to the black body. So we are almost at the end of the heat transfer chapter. I hope the previous videos which we are posted you gone through it and the doubts are clear to you. If you are any doubt you can comment on the video and we'll get back to it. Okay. So in today's lecture, what we are going to discuss is the radiative properties of the black body, what is the emissivity, what are absorptivity, reflectivity, transmissibility, and a black body radiation. And even at the end, we are going to discuss about the gray body. Okay. So basically, what is the black body? Okay. See, the black body is nothing but the body which absorbs all the radiation which are incident on its surface. Okay. That body we call it as a black body. See, generally what happens when the radiation falls on a body, some part of the radiation they are reflected, some part of the radiation they are transmitted, and some part of the radiation they are absorbed. Okay, but the black body is the one which does not transmit and neither it reflects the radiation, but it absorbs all the radiation which are incident on it. That's why it is appear to be a black, because it does not reflect any radiation which are falls on it. The emissive spectrum of the black body was studied by Max Planck. It is one of the scientists who firstly studied a spectrum of the black body. Okay, the radiation energy per unit time from the black body is proportional to, of course. Now this is the radiation law what we have studied, and it is basically applicable for the black body. That is the Stefan Boltzmann law what we studied. Now what is that law? We know that the energy per unit time for a black body is proportional to the fourth power of the absolute temperature. That is nothing but the Stefan Boltzmann law, which we already studied in the radiation, in the laws of the heat transfer. Okay, I hope it is clear. Next, we'll discuss now some of the radiative properties of the black body. Now, one diagram I have shown here. Okay, this is a diagram. Okay, so what this diagram indicates is, see, as I told you, when the radiation falls on any surface or any body, okay, it's common phenomena that some part of the light will be absorbed, some part of the light will be reflected, and some part of the light will be transmitted. Okay, so here we are going to discuss some of the terms which is related to this chapter. Okay, so let us go for the terms. Now see here, the first term is the reflectivity. Okay, so what the reflectivity means? See, it is the ratio of, okay, it is first of all, it is the ratio of what? It is the ratio of incident energy. Suppose if Qi is the incident energy divided by the energy which is reflected by the body. If Qr is the reflected body, radiation reflected by the body, then Qi divided by Qb is nothing but rho, which is nothing but the reflectivity of the body. Similarly, there is the transmittivity. So how you define transmittivity? The fraction of incident energy that are transmitted through the body is called as the transmittivity of the body, and which is denoted by a letter tau. So how you define transmittivity? Yes, how you define? Amount of heat transmitted divided by amount of heat incident on its body. Okay, similarly absorptivity is defined as a fraction of radiation or light which is absorbed to the total amount of the heat incident on it. It is nothing but the absorptivity, and you will find this relation when you add reflectivity, transmittivity, and absorptivity. You have to get value as 1. Okay, and in case of black body, yes, in case of black body, this tau and rho, these are 0, and you will get alpha equal to 1. That means whatever light incident on the body, all light will be absorbed. Okay, so neither it is transmitted nor it is reflected. It is totally absorbed by the body, and that is the reason why it appears a black. Yes, we'll go to the next slide now. Okay, yeah, this is what the emissivity what we already discussed. A black body is the ideal emitter, means if you compare the two bodies at the same temperature, then you will find that black body will emit a more amount of heat compared to that of the other body. Okay, this is what the emissivity or emissive power of the black body. Okay, now that's what it at the defined temperature, a black body has the highest monochromatic emissive power at all the length compared to that of the other bodies. Okay, and the ratio of emissive power of the real body means what? The body which exists actually. See, black body is the hypothetical concept. Okay, you don't have something called as the perfect black body. Okay, so it is just a concept. So what it states, the ratio of emissive power of the real body to the black body emissive power, that is EB. Okay, this is emissive power of the real body divided by emissive power of the black body, that is EB. At the same temperature, we call as the emissivity of the body. Okay, I hope it is clear for you. So I will move to the next slide. Okay, sorry. Now we'll study regarding the black body radiation and what are the characteristics of the black body. Now it is a perfect emitter. Yes, as we actually, these are the points which are already discussed now. A perfect emitter compared to the other body at the same temperature. Okay, at any prescribed temperature, it has the highest monochromatic emissive power of all the length. That's what it means. A black body absorbs all the incident radiation, and therefore alpha is equals to 1. This is what also I discussed, correct? The black body is the one which neither emits nor transmit the any radiation which are incident on it. That's why tau and gamma, they are equal to 0 for the black body, whereas alpha is equals to 1. That is the maximum power. It is a non-reflective, that's what tau equal to 0. It's a opaque, means it does not transmit anything. Opaque means what? The component or the body which does not transmit any power, we call it as the opaque body. Okay, so these are the points, important point of course, which are related to the black body. If they ask you to write the characteristics of the black body, you have to mention these characteristics. Okay, next. Yes, now we come to the gray body. Yes, now this is the real concept. Okay, so black body is just a hypothetical concept, means you cannot have a perfect black body which will absorb only all the radiation. Okay, so gray body is the one which partly absorbs some of the radiation, partly reflects some of the radiation, and partly transmits some of the radiations. Okay, this is what the gray body is, and gray body is the real concept. It is the actual exist in the nature. The absorptivity of the gray body is always lied between 0 and 1. Yes, correct. For black body, absorptivity is equal to 1, and other than the black body, the value of absorptivity is lies between the 0 and the 1. Okay, next, the emissive power of the gray body, yes, is always less than that of the black body, because black body we are assuming it's the standard which has the absorptivity equal to 1, that is the maximum. And the ratio of emissive power of the gray body, that is Eg to the emissive power of the black body. Okay, at a given temperature, is a constant and it is known as the emissivity of the gray body. Okay, I hope everything is clear from this presentation, and if you are having any doubt on this presentation or in this video or on the previous videos, you can comment on the video and we'll get back to it. Thank you one and all.